There we go. Cool, all right, so where are we? Where were we? We are trying to fix this bug with mutable chunks, and we got a suggestion from Gemini 2.5 Pro here, how to do this. And I thought it looks like a good suggestion, and I want to try to implement it and see how it works. So maybe we should just copy paste a bit of this and see if it works, and then refactor it to our purpose. I think that might be a good idea. So where are we? Git status. Yeah, everything is pushed, so we can play around a bit here. Yeah. Cool. So chunk group. Yeah, the effective size. It's actually a good idea to have a constant for that because I'm using that in a lot of places. Hash set. I think these two lines are new. Yeah, this Gemini seems so much better than Cloud on this stuff, on programming. I mean, we can remove this comment. This is just for us from Gemini. Interesting that this is not, it's not saying this is unused, but yeah, this is an import and this is a constant, so maybe it treats it differently. I already have this function, right? Chunk ID to world position translation. Yeah. Why are they skipping this? Oh yeah, I don't need to do that again here. Yeah, they're doing the same thing. The world position translation up here. Chunk set the position, just that we're doing this in one line. Chunk.fill. And then chunk. Can we, yeah, let's try to remove this. Actually makes sense. Yeah, we're just doing the same thing again. Yeah, this is a bug. Nice. helper to calculate the world position. Group world position. Yeah, I guess there's actually a difference between chunk world position. And group world position. Maybe I should make that clear. And this would be also a group. And then we'll use this here. Yeah. Good. Get chunks. Still the same. I should change this. Import actually. Chunk. We should import it like this. Do we use chunk? Chunk group size is not in there, no. Chunk. And material, because we're anyway doing that down there. Then we can delete this line. And yeah, we need to now rewrite this. Just as chunk. And I think we should do the same with material. Yeah, we're just using it in one place, but yeah. Material. Material. I think the tabbing in cursor is pretty good though. Okay. World position, get chunks. This is where we are. I just want to save this git status, git add, git commit, some minor refactoring in chunk group. Okay, logic for finding affected chunks. This is new. Get chunk indices. There was something about this I didn't like yesterday. What was that? Is this too small or is it okay? Should be okay, right? Gonna try on my phone. Looks okay. Calculate the indices of chunks within this group that contain or border the given world position. Yeah. Yeah, this is great. Relative position. Determine potential chunk indices based on division. Chunk effective size gives the base chunk index. If chunk size is 5, effective size is 4. Position 3.9 is in chunk 0. Position 4.0 is on the border. Position 4.1 is in chunk 1. Yeah. True. You would floor it, I think. Right? Because if this relative position here is 4.1, this would become a slightly above 1, and then you floor it, and then you know the index. Why do you check? This is what I don't understand, I think. Floor and floor plus 1. So then you would have, let's say in the same case, you would have slightly above 1. 0, 0, 0. You would have, yeah, let's say for x, you would have slightly above 1. You do plus 0, you get 1. You say, so that's 1. And then you would also do plus 1. So you would have 2. Why would you add 2 here? And they all need to be below, of course. Get the origin of the potential chunk. Chunk ID to world position translation. Yeah, exactly. What is this world position though? Wait, this is unnecessary, I think. Why? Yeah, we can just use self.world position here, I think. Why is this failing now? Oh yeah, of course. Um, this will be, oops. This will be self.world position. It needs to take self. Oh yeah, that's the problem. It hasn't been initialized yet. So it doesn't know about world position here on itself. It doesn't exist yet. That's why I couldn't do that. That's right. Okay. Still not understanding why it takes the ceiling here. I think this might potentially cause some weird behavior later on. Okay, this is why self.world position is actually correct here. Yeah. Check if the world position is actually within or on the boundary of this chunk. What happens in the case where we have just slightly above or just slightly below, let's say 3.9? Then we would have slightly below 1. Come down here. This would give us 0 and 1, which in that case would be correct. Check if the world position is actually within or on the boundary of this chunk. I feel like I don't really understand what's going on, and that's probably a bad sign. Might introduce a lot of unnecessary complexity and unexpected behavior. It's going to be very difficult to debug later. Because here it's just checking like if every point is just within. Let's bring up the paint program. What was it called? My paint. No, what was it called? Okay, let me. Oops. Let me check. That's great. And which bot did I ask about it? Was it Grok? Yeah, it was. Pinta. No. Maybe I just have to my paint, Pinta, empty paint was the name. Okay, it was just the last command. Okay, so for oops, for no, what? New, of course. All right. So if we look at it in 2 dimensions, I think this was much better yesterday. What happened to this app? Yeah, anyway, I think you can see that. Might want to make this a bit broader. Oh yeah, size. Yeah, there we go. Oh, what's flow? No idea. Well, okay. So it's a bit too big. So, all right. So we have a square or 2-dimensional grid like this. And if we have the point here, we want based on this one here, the middle line, this should go here. So it's gonna dig on this point because these are the actual points, right? Or are they? I'm very confused now. No, okay, these are the actual points. Here in the corners. So yeah, you're over halfway there, so it should hit on these two. And these are overlapping. So if you're at like 0.7, that's above 0.5. You wanna like you kind of wanna pin it up or down depending on the number. So this would become a 1. And if it would have been down here, like 0.4 would become a 0. So you want to round it. Don't want to seal or floor. Here, I want to round it. And then we don't need to do this. Or this. But and this might even be redundant. Or no, I think I know what's going on here. So what it's doing here, I think, is it checks. So if we are in this grid here, it's automatically gonna include this one as a potential index. It's calling it the origins of the chunks. I like that. Don't like this logic. I mean, I kind of see what it's doing here. Maybe that is a good idea. But it feels very brute force. What does it do with this information later? Dig. Get indices. Get a temporary mutable borrow. So yeah, it looks like this is actually just getting all potential neighbors. And then the action happens here when it tries to get the material. If it's in that chunk, it's gonna do something. It's gonna change the density. If not, yeah, it can't get the material. Okay, no, I want to rewrite this. I mean, we could probably return the same data structure. Okay, I don't want to floor it. Or yeah, I do. Base chunk index. Yeah. And then then yeah, when looking at this, need to remember that there are actually multiple chunks, multiple materials within a chunk. So if we're in here, it's not on a border at all. If it's in here, it is potentially on a border. Here it's not, because this is the point it's gonna want to get. But here it is. So first we need to know if it's even on a border material. Maybe I should ask the base chunk about the borders. This is hard. Okay, let's oversimplify this with one dimension first. So we have, let's say, 3 materials in each. I will have a world position, and this is either here, let's say, or here. I want to get this back for x. If it's here, and this is the one, what would I have to get back? It's not enough to just get back. Or maybe it is. If I ask the chunk, which point would this world position dig at? Which point will this dig at? If this point is one of the borders, then we know. We know. Yeah, I think that's actually it. Okay, so ask the chunk which index in the chunk this will dig on. That's a good idea. We just call ourselves and get the chunk indices. Good solution. If the index is on the border, add the neighboring chunk. To all right, so we want to write this something like Let's get the material. I think it's the material indices we want to give, not the chunk indices. Let base material index equals self.chunks. Get material index. Let's make that private for now. Or public. I wanna have some debugging going on now. I wanna see what's happening. Let base material index this. The chunk should know if this is on the border of itself, the material. Is this like a match statement? Because I kind of want to do something like this. If base material index.x 0 or base material index x, no, then this will not be potential indices. This will be we need a combination of chunk index and material index. So maybe not a hash set. Can we do a hash map? And this will be hash map of, yes. Is it better to use a struct here? I think it might be easier to follow if I do. Chunk material map. Index map. Chunk index, material index. Yeah. Yeah. Now I think what I need is chunk index as a struct. It's maybe a confusing naming. Chunk index, material index. So we should be able here to do, because we have the base material index, we have the base chunk index. Can we just do implement chunk index? Implement material index. I think it actually makes sense to make these structs because we're going to use these indices in the code a lot. Can I just do chunk index new? There we go. I actually want to create, though, another type for this combination. Let's play around with it. It's fun. We'll learn something along the way. Chunk material index. Yeah. Implement. Yeah. Oh, and then we'll do base. Yes. And this will be a hash set again. Right, I gotta go. This was fun. No code compilation, just coding and theorizing around the chunks. But I think, yeah, we made a little bit of progress today, I believe. Just feels like it. It's a hard problem, I find. But I'm sure we learned something, and yeah, keep getting at it, and hopefully this problem will be solved. This is a problem I came across for the first time like a year ago, and then I gave up, and now I'm at it again. I really want to make this work. Cool. I'll create a new branch with this. Git status, git add, git commit, refactoring the Gemini solution. And then let's do git branch b, no, git checkout. Gemini, we can call it the Gemini solution branch. Git push u origin Gemini. Cool. Right. Yeah, that's all for today, or at least for this session. I might come online again a little bit. Yeah, we'll see. No promises. Anyway, see you later. Bye.